Pythagoras Theorem. Pythagoras Theorem states that in a right-angled triangle, the square of hypotenuse side is equal to the sum of squares of the other two sides. Consider the right triangle PQR, right angled at Q. Angle Q is 90 degrees, means the right angle. And the side opposite the right angle, which is the longest side, is called the hypotenuse. About the other two sides, we can call side PQ as the base and side QR, we can call it the perpendicular. Now as per the Pythagoras theorem, the square of the hypotenuse is equal to the square of the base plus the square of the perpendicular. Hypotenuse square equals to base square plus perpendicular square. We can also write it as PR squared equals to PQ squared plus QR squared. Remember, this theorem applies only to the right-angled triangles. We can use this theorem to find the length of the third side of a right-angled triangle if the lengths of any two of its sides are given. So let's learn how to find the length of the third side of a right triangle given its two sides. Given triangle PQR right angled at Q. PQ equals to 3 cm, QR equals to 4 cm. Find PR. We are given PQ equals to 3 cm, QR equals to 4 cm, and we are required to find the length of PR. Side PR is opposite to angle Q, which is a right angle. That means PR is the hypotenuse. Therefore, by Pythagoras theorem, PR squared equals to PQ squared plus QR squared. PR squared equals to PQ squared plus QR squared. Therefore, PR squared equals to 3 squared plus 4 squared. As length PQ is given as 3 cm and length QR is given as 4 cm. PR squared equals to 9 plus 16. Since 3 squared is 9 and 4 squared is 16. PR squared equals to 25. If PR squared is 25, then what is the value of PR? If PR squared is 25, then PR equals to square root of 25. PR equals to 5. You saw now how we used Pythagoras theorem to find the hypotenuse when the other two sides of a right triangle were given. Now let's take another example where the length of the hypotenuse and one of the other two sides is given and we are required to find the length of the third side. Consider right triangle ABC, right angled at B. AC equals to 9 cm and BC equals to 6 cm. Find AB. In right triangle ABC, angle B equals to 90 degrees. Therefore, the side opposite to angle B is AC. So, side AC is the hypotenuse. Therefore, by Pythagoras theorem, AC squared equals to AB squared plus BC squared. Now AC we are given as 9 cm. AB is not given and BC is given as 6 cm. Therefore, 9 squared equals to AB squared plus 6 squared. 9 squared equals to 81 equals to AB squared plus 6 squared equals to 36. 81 equals to AB squared plus 36. Now in this equation, we need to find the value of AB. So AB is the variable and it's better if the side containing variable is the left hand side of the equation. So first interchange the sides of the equation. instead of writing 81 equals to AB squared plus 36, write AB squared plus 36 equals to 81. AB squared plus 36 equals to 81. Now keep only the variable term, that is AB squared, in the left hand side and move all other terms to the right hand side. To do this, write AB squared and put equal sign after that. And first write as it is whatever you have to the right side of the equal sign. No need to change the sign. So let's write here 81 without changing its sign. Now write all the remaining terms from the left hand side by changing their signs. We have plus 36 remaining in the left hand side. So we'll move it to the right hand side by changing its sign. So plus 36 is now going to be minus 36. 81 minus 36 is 45. Therefore, AB squared equals to 45. If AB squared equals to 45, then what will be the value of AB? If AB squared equals to 45, then the value of AB will be square root of 45. Therefore, the length of side AB equals to square root of 45. Square root of 45 can also be written as 3 root 5. Thanks for watching. Please subscribe to my channel.